Hi, good evening. I'm Dr. Philip McMillan. Thank you for joining me as we continue on this journey of investigating the science around the pandemic and asking difficult, inconvenient questions. Now, I was involved in a very important presentation yesterday about the death of a 34-year-old young man, and his mother was determined to find the cause. And it ended up with her taking um, parts of his organs for investigations in Germany. And there's a paper that is a preprint that we'll be able to go through. And this important work has highlighted some critical aspects about the pandemic that really need to be addressed. And largely it's about the lack of autopsies. And I will be coming to that in just a little bit. But sadly, as somebody has highlighted here, this video was removed yesterday, so it was taken off. So there is a version of it that is still up. But if you want to see the full version of it, you would have to be able to go to the link that is below in the description. And there you will find the full video. And you will have as well all of the full paper, some of the slides, some of the histology. So if you're interested in that, please click on the link below and you will be able to take a look at it. So before I go into the paper and the important aspects of this, I'd just like to remind everyone that if you are not yet aware, we have launched our Kickstarter program, Humming Heroes. It's already 30% funded. In order for it to work, it has to go to the full funding on Kickstarter, and that's a challenge in itself. But we want your support to start a different way of education. And this is essentially what we're taking a book, we're bringing the science, we're bringing a webinar, we're bringing a book, an ebook that explains the science around it. So, this is all in all a fascinating concept, and we would definitely love your support. Let's get back to the presentation today. And this was from the meeting yesterday. This here is Hetty Simoes. She's the mother. And the warning that I would give to anyone, and there are a lot of people who want to ignore these voices who are raising questions and challenging the science, is that these mothers are not going to go away. Heather, as well, is a mother whose son is quite sick, and she is not going to go away either. And so I'd advise those people, rather than trying to censor them, silence them, I would suggest that you get behind them and support them if you don't want to be overrun by them, because they are unlikely to stop and they are only going to get stronger in time. But it highlights this really fascinating case of a 34-year-old young man who, 16 days after he had been vaccinated with the first dose, died of aortic dissection. And I'll take you through the science of that in a minute. And this is the paper that I'll be going through, as I said. A case of myocarditis, pericarditis, and fatal aortic dissection following COVID-19 mRNA vaccination. What I've found fascinating about this is that technically, when his mum reached out to the CDC, all they gave her was a letter of condolence almost. And that was as far as they were going to take it. And that's part of the reason why she got so upset at the response after this had occurred. Before I go into the paper, I just want you to be aware of what exactly is going on in terms of the anatomy. So I'll just quickly run through some of these slides that I did do yesterday. But here you have a picture of two hearts, the same heart, really. This is the full heart. This part here is the right ventricle. This is the left ventricle here. You'll see it better on this slide. This is the cut section. So this is the right ventricle that pumps the blood in blue. That's blue area here. This is the pulmonary artery. It goes through the lungs before it comes back. And then the blood is pumped. When it comes back from the lungs with oxygen, it is pumped through the aorta here, and that is then sent throughout the body. So this is the aorta here, and this is the part that was dissected or torn apart. And so, to understand the science of it, let's just take it a bit further. This is a picture of the aorta here. Same heart, it's pumping blood all the way through the body. The arteries here are going up to the brain. This is the axillary artery going to the left arm, and then it goes down into the leg. So this is the main part, the ascending aorta, the arch of the aorta, and then the descending aorta is here. Now, when we're thinking of dissection, this is what it could look like. So this is just a picture of an artery here. And this artery here has an endothelium. So this dark red part is supposed to represent blood. This is the lining, the endothelial cells. And then there is a bit more of an elastic collagen lining just underneath that to give some strength. Then you have the muscle layer here. And then you have another elastic layer, which we'll come to in a little bit more detail at the in another slide. And this is the example of a muscular artery. And the aorta is the largest muscular artery that we have. And in this picture, it shows what would happen with a dissection. And you can see it has torn through this, the intima here. And the blood is then, because the pressures are so high, is forcing through into the muscle. And then it can rupture and go and bleed into the thoracic cavity, which can be quite catastrophic. So this is quite a significant event, and something that, from a clinical point of view, is treated with utmost seriousness and an emergency. In the case of Victor, who passed away, he died within an hour of him having symptoms. So that's how quickly it can be. This is an image showing you the different kinds of dissection, the DeBakey classification. And you can see here, this is type 1, the most serious. In effect, this is where the tear that occurs here is going all the way through, from the ascending through the arch down to the descending. In type 2, it's just the ascending. In type 3, it's just primarily the descending. This one would be considered the most serious and is likely to have been part of the reason in his case why it was a significant terminal event. I've taken this other slide here from Gray's Anatomy, and this is just showing you here the layers of a muscular artery. And you can see here, this is very important for you to understand when we talk about the histology, is these blood vessels and veins here, the vasa vasorum, and these are in the outer part of the artery and supply oxygen and nutrients to most of the artery. It also has some pain fibers in here, which are important to note. But you can see here, and I'll make this just a little bit bigger so that you can see it. So as I said here, this is the blood vessels in the lining of the muscular artery, the vasa vasorum. And then on the inside here, this yellow bit that we've got highlighted is the external elastic bit. So this is what allows it to expand and contract. And then on the inside of it, you have the muscle layer. Then you have another bit here. This is another elastic fibrous bit. And then on the inside here, this is the intima. That's the inside bit that usually tears first in an aortic dissection. So this whole breakdown is quite important in order to understand what the paper is talking about. So we're going to go back to the paper to try and understand a little bit more about what had happened. So this is the abstract of it. He was 34 years old. He was in good health. And 16 days after he had his first dose, he experienced acute inflammation with dissection of the thoracic aorta and what they call pericardial tamponade. And what that means is that the tear went down into the sac around the heart. And this is what was the terminal event, that because that filled up with blood, the heart couldn't pump. And then he would have collapsed, which is exactly what happened at the scene. And sadly, he passed away within an hour. So this is the a sense of exactly what happened. And his only symptom was chest pain, I think, at the time before he collapsed. And it was because he was feeling unwell with the chest pain, why he called the ambulance service at the time. But it raised a question in my mind as I realized that there are many people who have been struggling with chest pains and we can't find a cause. And just this case alone has raised that question in my mind as to whether or not inflammation of the aorta could be part of the reason. And this is why it is so critical to understand the histology around what is going on. How do we mitigate it? By looking for it. But how do we look for it if it's not acknowledged? This is where we are at the moment. And this is the sad state of affairs that we have, that sadly, people still have to fight to get what should be standard research, standard requests done. We give credit to Hetty for what she has done here because her persistence has answered many questions already that I've been looking for through the use of autopsy. Let's hope that more people stand up, insist on the histology. Don't let anyone tell you otherwise. Without that, we can never be sure. Histology in autopsy is the audit that no one can deny. Have a great evening.